In question number 31, white light is passed through a prism of angle 5 degree. If the refractive indices of red and blue color are 1.641 and 1.659 respectively, then we want to find the angle of dispersion between red and blue color. The angle of dispersion is given by mu b minus mu r into a. That is 1.659 minus 1.641 into angle of prism is 5 degree. Simplify this, we will get delta is equals to 0.09 degree. So option 3 is correct option. In question number 32, a crown glass prism of angle 6.2 degree is to be combined with a flint glass prism such a way that the mean ray pass undeviated. The angle of flint glass prism needed we want to find, that is A2. Given the refractive indices of crown glass is 1.517 and that of flint glass is 1.620. Here, for the ray to pass undeviated, the deviation produced by these two prisms should be equal. So mu1 minus 1 into a1 is equals to mu2 minus 1 into a2. So 1.517 minus 1 into 6.0 is equals to 1.620 minus 1 into a2. Find the value of a2. We will get a2 is equals to 5.17 degree. So option 2 is correct option. In question number 32, a crown glass prism of angle 5 degree is to be combined with a flint glass prism of unknown angle of prism A2 in such a way that the net dispersion is 0. The refractive index of violet for crown glass is 1.523 and that for red is 1.514. Refractive index for violet for flint glass is 1.632 and that for red is 1.614. Here the dispersion produced by both the prism should be same. The dispersion is mu v1 minus mu r1 into a1 is equals to mu v2 minus mu r2 into a2. Put all these values and solve for a2. We will get a2 is equals to 2.5 degree. So option 2 is correct option. In question number 34, a thin prism deviates blue and red rays through 10 degree and 6 degree respectively. That is delta B is equals to 10 degree and delta R is equals to 6 degree. The another prism deviates blue color by 8 degree and red by 4.5 degree. We want to find the ratio of dispersive powers of the prism, that is omega 1 by omega 2. The dispersive power is given by delta V minus delta R divided by delta Y, and delta Y is equals to delta V plus delta R divided by 2. So W1 by W2 will be equal to 10 minus 6 divided by 10 plus 6 by 2, that is equals to 8, divided by omega 2, that is equal to 8 minus 4.5 divided by 12.5 divided by 2, that be equal to 6.25. Simplify this value, we will get omega 1 by omega 2 is equals to 25 by 28. So option 3 is correct option. In question number 36, a prism produces minimum deviation delta. 3 such prisms are combined. Let's say they are combined in this way. This is prism 1, prism 2 and prism 3. Now what will be the minimum deviation? Here these two prisms, as all three are identical, these two prisms will cancel out each other's effect, so the net deviation or minimum deviation will be still delta. So option 3 is correct option. This question was question number 35. In question number 36, it is given that a light is refracted by a prism such that angle of deviation is minimum. For minimum deviation, the angle of incidence should be equal to angle of emergence. R1 should be R2 is equals to A by 2. So option 1 is correct option. In question number 37, a small angled prism made of glass is immersed in a liquid of refractive index 1. So the surrounding medium, we can consider it as air, because air is also having refractive index 1. The ray of light is made to incident on it. We know in the case of air, the finally emergent ray will be in this direction. So the emergent ray is bent towards the base of prism. So option 4 is correct option. In question number 38, 3 prism 1, 2 and 3 have same angle of prism 6 degree. But the refractive indices are mu1 is equals to 1.4, mu2 is equals to 1.5 and mu3 is equals to 1.6. Their angles of deviation are delta 1, delta 2 and delta 3. We want to compare this angle of deviations. Angle of deviation is given by mu minus 1 into A. Here angle of prism is same for all 3 prism. So we can say delta 1, delta is directly proportional to mu. So delta 3 will be greater than delta 2 will be greater than delta 1. So option 1 is correct option. In question number 39, it is given that when white light enters a prism, it gets split into its constituent colors. This is due to the reason for splitting of white light into different color is the white color is the combination of 7 different colors, that is 7 different wavelengths. The refractive index of given material is different for different wavelengths of light. So each light will travel with different speed because they have different refractive indexes. So option 2 is correct option. In question number 40, it is given that a white light is passing through a hollow prism. When a white light passes through a hollow prism, there is no medium to change the speed of different colors or different wavelengths. So the light will travel with same speed as that before entering the prism. So there is no dispersion that is no splitting and no deviation. So option 1 is correct option. In question number 41, we have to find in which of the following does not exhibit dispersion. The main reason for dispersion is the non-parallel surfaces. In this case, these two surfaces are parallel to each other, so this will not exhibit dispersion. So option 3 is correct option. In question number 42, in dispersion without deviation, the yellow color light is parallel to the incident ray. So option 2 is correct option. In question number 43, in the visible region, the dispersive powers and the mean angular deviations for ground glass are omega and d, and that for flint glass are omega dash and d dash. We want to find the condition for getting dispersion with zero deviation when the two prisms are combined. So the total deviation should be 0, that is theta plus theta dash is equals to 0. So omega d plus omega dash d dash should be equal to 0. So option 3 is correct option. In question number 44, in the achromatic prism, we have deviation but no dispersion. So option 1 is correct option. In question number 45, among the following, the dispersion or angular dispersion will be maximum for which pair? The angular dispersion will be maximum if two lights of highest and lowest wavelengths are used. So from the among option, the wavelength difference is maximum for red and blue light. So option 2 is correct option. Thank you.